Right, which questions on the chart right do you want to see? We can go over and have questions about. On your name. If you have something other than 3 or 5, keep your hand up. Everyone else put your hand down. You can have a little faster to be able to. Thank you. We'll do 3, 4, and 5. So number 3, we had to translate the algebraic expression into words. There were different ways to do that. I'm just going to write down one if you want to give me what you wrote, and I can say if it's right or not. One way to write this: 3 times the difference of x and 2. I'm going to put a comma and then put squares. That's going to show that all of that's been squared. And then I'm going to put another comma, all added to 5. That would be one way to write that. Anyone else want to give theirs to see if they were right or wrong? Of x and 2 comma squared. Don't do that because it doesn't have an equal. Okay. Number 4, there were 2 x-intercepts and 2 y-intercepts. For the x-intercepts, -5 and +4. So write them as ordered pairs. -5, 0, and 4, 0. And then for the y-intercept, again, 2 of them at 6 and -5. So 0, -5, and 0, 6. Questions on either of those? Right. And then number 5. On the back, we are transforming really these two graphs or comparing the original to this one. In part A, it's shifted up because it's positive. The y-intercept is positive. Part B, the slope is less steep because it's a fraction. And the negative reflected the slope. We need all 3 answers in order to get that full point: up, less steep, and reflected the slope. You could put A, B, and then C, or you could just write out the 3 answers. Next. If it's a negative slope in general, it reflects. The negative has nothing to do with the steepness. Go ahead and make sure your name is on your Shark Bite answer sheet and pass those up. And then look at your course calendar. We're going to talk about some things. All right, look at your course calendar. Couple things I want you to notice. One, this is yours and 5th period. Your dates are not the first dates. Weird, because usually you are, because I usually see you first. So your dates are the non-bolded dates. Right, my bad. I was thinking your dates are the first dates. My bad. I was thinking I already said this. Anyway, your dates are the first dates. Ignore what I just said, not the second dates. But usually I don't see you first. That's what I meant to say. Okay. Does math, you have 2 due this Friday, 1 due next Friday, 1 due the following Friday. We are doing 4 lessons, but there are 3 objectives. 2 of them are combined. Your quiz is towards the end of the month in a couple weeks on the 23rd. Tests same week on the 25th. Flex day after that. This unit is going on quarter 3. So that means we have done everything for quarter 2. So your grade is going to stay as is unless you retake or take a missing test if you're missing one. So keep that in mind. Questions about anything date-wise? We are doing more linear things. Today we're talking about or starting systems. So let's talk about some definition. I'm gonna have you guys write this down. Systems of equations are 2 or more equations with the same variables. So previously we were really just focusing on one equation, except for when we did translating equations. But now we will have 2. Graphically, the solution to a system is the point xy where the 2 lines intersect or cross. Algebraically, the solution to a system, the point xy that makes both equations true. We'll talk about what that means here in a moment. And then, to the best of your ability, draw this in. There are 3 types of solutions. Intersecting lines. That's going to be your one solution, your point xy. Parallel lines, so think back to when we talked about parallel lines and what you know about them. They will never intersect, so those will be no solution. And then we have the same line. If they lie on top of each other, they are graphed the same, they have the same equation. That is infinitely many solutions. So the types of solutions isn't new, because we've talked about those before. Now we're just putting them to different types of systems and lines. And the ways we solve by graphing is 1, rewrite the equation in slope-intercept form if it's not already. 2, graph the lines. And depending on how the lines are graphed, you can see what type of solution they have. When you're finished, put your We're going to start with number 1 on the same page. So these are already in slope-intercept form. If you want a ruler, you can go grab one. I'm going to grab these in 2 separate colors. You don't have to, but if it helps you see them, you're welcome to do that. So for this first one, where would we start with graphing this first equation? Y equals x minus 8. Where do we start with graphing? Y on top, negative 8. So go down negative 8. I think this is a 10 by 10. Just if you want to skip instead of counting. And then what is the slope of this one? one, so we're gonna go up one to the right one as many times as possible, fill up your graph. And down one, left one as many times as possible, fill up your graph. Once you have all of your points, go ahead and connect the dots, make a line, draw arrows at the end, because lines go on forever and ever. Yeah. Okay, and then draw the other one. I will say, without graphing this, you could see that these are not parallel, they do not have the same slope, so it wouldn't be no solution. These are not the same, so it could not be infinitely many, it would have to be one solution. You just have to find what that one solution is. So this one would start at +1. The slope is -2. What directions could I go to get a negative slope? Down and left. Down and right, so they have to be opposites. Go down to right one as many times as possible. And up to left one as many times as possible. Draw in your line. And you should be able to see where those two lines cross. Where do they cross? -5. 3, -5. So you would write that in ordered pairs in the solution box. Questions on how we solve systems by graphing? Let's do the second one. Graph both of those. Does not matter which one you graph first. I'm gonna start with the first one. Y-intercept is 9, slope is +1/2, so I can go up 1, to the right 2, down 1, to the left 2, as many times as possible. Draw your line, make sure it has arrows. And then draw your other one, starting at +6. What's the slope of that line? -1, so down 1, right 1 as many times as possible, up 1, left 1 as many times as possible. Fill up your graph. What is that solution point? -2. It is one solution, but make sure you're listing what the solution is. When we get back from lunch, we'll do a couple more on the next page and then go on back. So we'll have to change both of these. So I'm gonna do this simultaneously. Add 3x to the other side. And add x to the other side. Now y equals 3x plus 8, and y equals x minus 2. And then I'm gonna graph both of those. Minus 2. Before we graph it, which type of solution is this gonna have? One. Positive 8, slope is positive 3. If I went up, I'd be off the graph, so you don't have to do that point, but you can go down 3 and left 1 as many times as possible. And then -2, slope is positive 1/1, apply as many points as. What is the solution there? Of these other ones on this page, are there any you want to see you go over? Were there any ones we wanted to see you go over before we move on? As you graph solutions, if you have parallel lines, you would graph them both. But if you have infinitely many solutions, I'm just going to play you out, where is that one? So I'll solve this really fast. So if you were to solve number 4, the first equation, and look at the two equations, they are the same, identical. That would tell you, without graphing this, this is gonna be infinitely many solutions or the infinity sign. That was a terrible infinity sign. You still need to graph it. So I would say graph one of the equations once. Start at 2, go up 1 to the left 2 as many times as possible. Yes. And then you can do one of two things after you graph. You can either extend arrows and draw them outside of this. I'll show you what to do. So along this, I can extend the arrow to show that it's like 2 sitting on the same line. You could highlight over that same line with arrows to show that both are graphed on top of each other. Or you could regraph the same line with a different color, like red on top of it. So with your infinitely many solutions, do one of those things, yes. That one, yes. Okay, go on to the next page. And then after this page, you guys will have time to practice after I share the homework. So here in our definition of algebraic, it's what makes it true. So if I wanted to see if, let's say I was given this solution, system of equations, and I got this as a solution, how could I check to see is this right or not? What were you gonna say? Oh. You could put it in the graph and that would show you, else algebraically could be different.
So both y, if they both equal y, then technically, is that good? Technically could make them equal.
You could do that and solve and then figure out the x value and then see what the y value would be, Chris. That would be the fastest way. Graphing might be faster also, but you can put these both into x and y. So let's do that. So if I put this into both and they both work, then it's the solution. If one of them does not work or both of them does not work, it is not the solution. Let's do this first one. 2 equals negative 1/3 times 3 plus 3. If I multiply these together, I would get what? 1, negative 1. And then negative 1 plus 3 is 2. So that works. But both of them have to work, so let's check the other two. So then we have 2 equals 2 times 3 minus 4. 2 times 3 is 6. And 6 minus 4 is 2. That also works. It works for both, so I can say yes, this is the solution. This would be the point that makes this true. Let's do another one. Number 3. Same process. You do not need to solve this, get it back in slope intercept form. You can if you so choose, but you don't have to. So if I put these in for x and y for the first pair, I have 4 minus 4 times negative 2 equals 12. And then simplify. It's 4 plus 8 gives 12. And then for the other one, 3 times 4 minus 2 times negative 2 equals negative 4. We have 12 plus 4 equals negative 4. Is this going to give us negative 4? So because this one did not work, this cannot be the solution.
That will be right, no solution.
So not that it's no solution, because we're just checking to see, let's say you solved this, or you solved it by graphing, or later when I show you how to solve by substitution elimination. Let's say you got this as an answer. This is a good way to check yourself. If you get one that works, but one that doesn't, something in your work was wrong. Or maybe you graphed it incorrectly or something. I want you to do 2 and 4 really quickly. I'll give you a couple minutes to do that. Okay, for number 2, do we think this is or is not a solution? No. Anyone need to see that one? What about number 4, is or is not a solution? Yes. Anyone need to see that one? Okay. So if I put these in, I have 5 times negative 2 minus 2 times negative 1 equals negative 8. So -10 plus 2 equals -8, and -8 equals -8, that works. And then for the other one, 3 times -2 plus 2 times -1 equals -8. So we have -6 minus 2, which does equal negative. On that same page, numbers 5 through 8, we're just gonna do one of these. For number 5, I want you to state the system of equations and the solution. The order doesn't matter. So let's say we were stating the solution first. What is that solution? -2, -1. And then to state the system, we just have to write the equation for both lines. I'm gonna highlight one of these, change the color of it. So of my green line now, to write the equation, I need to know the slope and the y-intercept. What is the slope? For this one?
Oh, sorry.
-2. -1/2 and the other one is right. And then the y-intercept? 4, this one, 4, -4. So y equals -3/2 x minus 4. And then for the other one, we already said that that is a slope of -1/2, and the y-intercept is negative. So it's just being able to, now you're given the graph instead of you having to graph. Go back and forth. Questions about that? Look on the very last page. So I'm going to show you how to do this in Desmos and in the calculator. And just so that when you're practicing, you can check yourself very easily in Desmos / the calculator. So in your calculator, you're going to go into y equals. Actually, read at your calculator first. Second plus 712. Second plus 712. You don't need to hit enter. Right, and then go into y equals at the top. And we're going to type in number 1. Alpha y equals 1/7 x plus 6. And alpha y equals 9/7 x minus 2. And then you're going to graph it. If you can see where they cross, then you can either try to count this. My eyesight isn't the greatest all the time, so I miscount. So to confirm, I could go into second trace. Which of these do you think we're looking for? Intersect, so number 5. And then it says first curve, that's really just your first line, hit enter. Second curve, it will jump to the second line, hit enter again. You don't want to guess, you want the calculator to do the work, hit enter one more time, and it'll tell you what the intersection point is. That way you don't have to count / miscount, and you get the right answer.
Click second trace.
Second trace, yep. So there's a good way to double check any system of equations as long as it's in slope-intercept form. It's only set back with the calculator. It has to be in slope-intercept form. Desmos, it doesn't matter. So while you're taking your test, you could double check this, but not on Desmos. I'm going to show you on Desmos as well. And I'm going to do the second one. You do not need to solve this in order to put it in Desmos. You can put it in exactly as is. It will graph the equation. And then you can see really quickly where those two lines intersect.
So we just bring in
The solution. So if you're checking yourself, this is a way to check yourself, not I did it in the calculator answer. You still need to show your work, especially for graphing. You need to show the graphs. Questions on how to check yourself in Desmos or the calculator? You can graph it. So it wouldn't be a problem like this. It would be a problem like 1 and 2, 3, the first ones we did. Okay, so then for the rest of class, you can be working on one of two things. Either more practice from the notes, go through, work on those, or you have a document that's due on Friday on this that you could easily knock out. If you want an iPad to use Desmos or double check yourself in Desmos, feel free to grab one. Let me know if you have any questions. You guys can work together, move around. Make sure we are actually working on the iPads, not in the camera.